Hello, good morning. We're about having a lecture on CHM 102. Just wait, let me share my slides. Maybe you can see my slides. So we're having a lecture on the determination of structure of organic compounds, including qualitative and quantitative analysis in organic chemistry. So determining the structure of organic compound is essential for the understanding of the chemical behavior, synthesis, and applications of such compounds. And this involves qualitative and quantitative analysis. Of course, the qualitative identifies which elements and functional groups are present, while the quantitative determines the exact amount of each element in that compound. So we also have spectroscopy and chromatographic methods, and this helps to reveal detailed structural features using physical data. For the applications and across pharmaceuticals, forensic science, food chemistry, and environmental monitoring. So let's look at qualitative analysis, using it for element detection. So you know that organic compounds primarily contain carbon, nitrogen, oxygen, sulfur, and halogens. So the analysis has to start with the identification. So we're going to use Lassen's test for this. It's a classical qualitative analysis, a method that is used to detect the presence of nitrogen, sulfur, and halogens in organic compounds. And this involves fusing the organic compound with sodium metal, convert it to convert the covalently bonded elements into their ionic forms. Then this is extracted and tested. So how is this carried out? First of all, you have to prepare the Lassen's extract. So you take a piece of dry sodium metal. The piece of sodium metal is heated in a fusion tube until it melts, forms a shiny material, shiny substance. Then a pinch of the organic compound to be tested is added, and the mixture is heated strongly to initiate the fusion reaction. After that red hot fusion tube is plunked into a china dish that is containing distilled water. So the content crushed using glass rod, then heated to boiling. That solution is then filtered to remove insoluble matter. And then you have that Lassen's extract, which you're going to use further. So now how do you detect nitrogen? So to a small portion of your Lassen's extract that you have prepared, add few drops of freshly prepared ferrous sulfate solution. Heat the mixture and add few drops of ferric chloride solution. Then add some hydrochloric acid to acidify the solution. When you do this, observe what you will see will be a Prussian blue coloration, which indicates the presence of nitrogen. What is the chemistry behind this? Sodium cyanide formed during fusion reacts with ferrous ions to form ferrocyanide ion. So when it is oxidized, these ions form ferric ferrocyanide. This ferric ferrocyanide that imparts the Prussian blue color. Confirm that you have nitrogen in your compound. So now what of sulfur? How do we detect sulfur? We use nitroprusside test. So to that same small portion of your essence extract, add few drops of sodium hydroperoxide solution. When you do this, if you observe a purple coloration, then it indicates that there is presence of sulfur. Chemistry behind this is that sodium sulfide formed during fusion reacts with sodium nitroprusside to produce the purple color. Still also, detection of sulfur, again, you can use lead acetate test. So you're still using a portion of your essence extract, add acetic acid to acidify the solution. Then you add few drops of lead acetate solution, and you observe the formation of black precipitate, which indicates the presence of sulfur. Chemistry behind this is that hydrogen sulfide gas that is released during acidification reacts with lead acetate to form lead sulfide, which is black. So detection of halogens, you will still use small portion of the essence extract, add concentrated nitric acid, boil the mixture, cool it, and then add silver nitrate solution. The observations here will tell you what particular halogen is there. If you have a white precipitate of silver chloride, then which is soluble in ammonia solution, then that is chlorine. If it is pale yellow precipitate of silver bromide, a pale yellow precipitate is formed as silver bromide, is partially soluble in ammonia solution, then you know that it's bromine. You have the yellow precipitate of silver iodide and is formed. This is insoluble in ammonia solution, then you know it is iodine. And the chemistry behind this is that sodium halides formed during fusion react with silver nitrate to form the respective silver halides. And so, to stop the lecture here, to stop sharing. And